Hello, this is Mr. Stansbury. I'm going to take you through the 4B notes on Pythagoreas and geometrical figures. At the end of this, you should be able to use Pythagorean theorem to solve special geometrical figures. All right? So, first thing is let's look at those special geometrical figures. Look at, aren't these special? Rectangle, square, rhombus, isosceles, and equilateral triangles. So, with this, again, I really hope you remember this, but rectangle, really the only thing you need to know is that all the angles are right angles, all right? With the square, same thing, all the angles are right angles, and, whoa, that's not so good. And then also another important thing to remember on this is that, goodness sakes, that I can't apparently draw diagonals on this pad, but that's all right, is that on a square, the diagonals bisect each other so that all of these sides are actually equal, and then also all of these angles are right angles here as well. So that's important to know about a square. Rhombus, also when you draw diagonals, which that is not a diagonal, goodness sakes, the diagonals on a rhombus also bisect each other. So this length is the same as that length, and then this length here is the same as that length there. And also, just like the square, all these angles in here are right angles. Okay? On isosceles and equilateral triangles, if you draw an altitude, goodness sakes, I will get this, don't you worry. Oh my gosh, that is just terrible. Okay, we're going to have to pretend that that's a good altitude. So, draw an altitude, those are right angles down here. And then this side is equal to that side, that's the isosceles part of the triangle. And then when you draw that altitude, this down here becomes the same length as that down there. And this is also the same. Alright, so draw an altitude down here. Those are right angles. This side's the same as that, and then this side is the same as that side. Alright? Okay, let's take a look at some examples. Alright, first one we're going to take a look at is example 7 from page 91. And that says the longer side of a rectangle is 12 centimeters and its diagonal is 13 centimeters. Find the length of the shorter side and find the area of the triangle. So, I always like to draw a picture of what the heck they're talking about. For me, that always seems to make a little bit more sense. So, longer side of the rectangle is 12 centimeters. Its diagonal is 13 centimeters. Okay, let's see if I can draw a diagonal. That's not too bad, comparatively. And we know that the diagonal is 13 centimeters. Find the length of the shorter side. So we got to figure out what this piece over here is, right? Now again, rectangle, important part to remember is that that's a right angle. So with that we can use a squared plus b squared equals c squared, right? So again, the important part here is that this has got to go in for the hypotenuse. So there's 13 squared, and then we say have 12 squared plus x squared equals 13 squared. Right, so that's 144 plus x squared equals 169. Subtract 144 from both sides, and we get that x squared equals 25. Alright, now we don't want to know what x squared is, we want to know what x is, so we have to square root both sides. And we get x equals plus or minus 5 centimeters. But again, you can't have a negative length, so x is 5 centimeters. And I always like to go back and look at what the question asks. Find the length of the shorter side. So then I would just maybe write the length of the shorter side is 5 centimeters. That's just a little bit more, x is 5 centimeters, but this is just a little bit more accurate of an answer. Okay? So, next thing we need to do is find the area of the triangle. Well, since we have our triangle, why does that say triangle? That should say rectangle, shouldn't it? Rectangle. Alright, so find the area of the rectangle. Again, we know now that this is 5 centimeters and this is 12 centimeters. So the area is going to be 5 centimeters times 12 centimeters, which gives us 60 square centimeters. So the area of the rectangle is 60 centimeters squared. Alright? Okay. Let's take a look at another example. And this is going to be example 8 from page 92. Okay. This one gives us that a rhombus has diagonals of length 6 centimeters and 8 centimeters. Find the lengths of its sides. Okay. So remember, a rhombus is basically just a square that got squished. Right? All the lengths of the rhombus are the same. Right? So these, all four of those sides are the same. And golly, cannot draw a diagonal. There we go. Close enough. And so we have our diagonals here. Pardon the squiggly diagonals, and it gives us the lengths are 6 centimeters and 8 centimeters. Now remember, the diagonals of a rhombus, this diagonal here is cut in half by this diagonal. And then this diagonal here is cut in half by this diagonal as well. So each of these pieces, 6 centimeters, just got cut in half. So each of those are 3 centimeters long. So this is 3 centimeters, this is 3 centimeters. And then this other diagonal got cut in half, so that's 8 centimeters divided by 2 gives us 4 centimeters. So this here is 4 centimeters, and this is also 4 centimeters. And remember, all these angles in here are all right angles. Okay. So to maybe make this a little bit more clear, let's pull one of these triangles out. So because we only need to find one side. Because once we find one side, we found all the sides of the rhombus because they're all the same. Okay. So this is this piece right here. So this is 3 centimeters. This is 4 centimeters. And that's what we're looking for. Right? So again, just go to old Pythagorean theorem. A squared plus b squared is going to equal c squared. X is the c in this case. So then we just do 3 squared plus 4 squared equals x squared. That's 9 plus 16 equals x squared. So x squared is 25. Square root both sides. And we get that x is, again, plus or minus 5, but we're just going to get 5 because you can't have a negative length. Okay? So the lengths of the sides of the rhombus are 5, we're going to put our tag on there, 5 centimeters. 5 centimeters. Alright? Okay, one last example to take a look at, and that is example 9. Alright, now I modified it just a little bit. They had a triangular garden, so I decided to make Monstro instead. So Monstro, the feared alien with an isosceles triangle-shaped head, has 2 sides of his head that are 12 meters, and the other side is 10 meters. Find the altitude of Monstro's head, and then find the area of Monstro's head. Okay, so first, of course, we must draw a picture. of Monstro. I will get this. Golly, it just right in there. It always goes. It's like there's a. Well, I got this one. Ready? Ugh. Okay, this is going to be it no matter what. There we go. Okay. So there's Monstro's head. Right, let's make, Monstro's body. Here he is, his big muscles. And his big club fists. Okay, as you can tell, I'm not an artist. So, here is Monstro. We have to figure out what the altitude of Monstro's head is. So here is, let's draw that little altitude. So these are right angles. That length there is the same as that length there, and then this is the same as that. And we know that this is, the two sides of his head are 12 meters. So this is 12 meters by 12 meters. Hey, that kind of looks like a monster. Look, there's the eyes. I don't know, there's like his teeth and his, I don't know. We'll go with it. Let's see, these sides down here have to be, are 10 meters cut in half, which is 5 meters. So this here is 5 meters and this here is 5 meters. Right? So the altitude that we're looking for is this piece right here. Is this new line that we drew. Why don't I draw that in green? Okay, so we're looking for that green altitude. Okay, so we can go back to our dear friend Pythagoreas. A squared plus b squared equals c squared, because again, it's a right triangle. The 12 meters has got to be the c squared, so there's 12. And then the other two sides are 5 squared, and let's call it x squared. 25 plus x squared equals 144. Subtract 25 from both sides, and we get that x squared is 119. Right? So we don't want to know what the x squared is, we want to know what x is. So we square root both sides. X equals the square root of 119 meters. Right? It's not terribly satisfying, so let's actually calculate it to see how, the altitude of Monstro's head is. Okay, so let's figure that out. Let's take the square root of 119. We get 10.908, so let's call Monstro's head as x equals 10.9 meters. We'll put little dots here and there. That means about. A little equal sign with the dots above and below mean approximately. Okay, so altitude of Monstro's head is approximately 10.9 meters. So the altitude of Monstro's head is about 10.9 meters. It's a big head, Monstro. To find the area of Monstro's head, we just need to, basically it's two triangles, right? So we can find the area of each triangle, or you could just find the area of the big triangle, right? Because you have the base, and we now figured out what the height is, so let's just do that. Right, so let's just redraw Monstro's head. And again, the part that we really want to know is this, which is, let's leave it as a square root of 119. And then also that this is 10 meters. Square root of 119 meters is the altitude, and 10 meters is the base, right? So area is going to be 1/2 the base times the height. So in this case, area equals 1/2. Base is 10 times the height, which is square root of 119. So area equals 5 times square root of 119. Let's go back to our calculator. So there's our square root of 119. Let's just multiply that by 5. And we get that the area of Monstro's head, is 54.54 meters squared. Monstro has a big head. Okay. Area of Monstro's head is about 54.54 meters squared. All right, so that's it. If you have any questions, feel free to ask. And I'm going to doodle on Monstro a little bit. We should make these red for fangs. And then, I don't know, should we give him some, let's give him some eyes. And maybe some curly orange hair. And Monstro, of course, should be squashing a building of some sort because he's Monstro. And of course, since he's squashing this building, it's on fire. Yes, I know what you're thinking right now. Wow, what incredible artistic prowess I have. All right, bring me in your beautiful pictures of Monstro.